talk about mechanical advantage. But before I get into that, I need to ask, if you do remember, we spoke about the 6 machines, we spoke about one of them being the lever, and then we went further to talk about the lever being broken up into 3 classes, the first class, second class, and the third class. So, today, mechanical advantage. I want you to look at this diagram before I proceed. This happens to be a rock. This happens to be somebody's hand that's going to press on the rock. This is the ground. This is the ground. So that example could be shown using this. Here's the rock. Here's somebody's hand over here. Here's the rock. And imagine that this part is touching the ground. If I label those pieces, then I'm going to label that as the effort. I'm going to label that as the fulcrum. I'm going to label the rock as the load. That is a drawing that we can find out there. Now I'm going to take that, I'm going to convert it into what we say as a system diagram. Now the system diagram will be shown like that. It will be shown like that. And that. So here we have it. E, fulcrum, and load. Do you notice I didn't write the letter F? So, look at that distance, and then look at that distance. That part is called the effort arm, and that part is called the load arm. Now, the effort arm is basically the distance from the effort to the fulcrum. This one is the distance, again, from the load to the fulcrum. So there it is, that distance, and then that distance. Why that is important? That is important because I'm going to show you how we get around calculating what mechanical advantage is all about. Because we want to establish if the first, the second, and the third class give us mechanical advantage. Remember, mechanical advantage is another way of saying make our job easier. What makes our job easier? So, here is an example to continue explaining mechanical advantage. I'm going to take a scissor. Now, to show you what the scissor is all about, in terms of system diagram, I'm going to show you that. Let's look on the side. Here is the scissor. That part is the turning point. That's where my fingers would go. That's where my fingers would go. And that is something that I am wanting to cut. So that is going to be called the load. That part there is called the fulcrum. And that would become the effort. So, there we got the scissor. F, R, and then E. F, R, and E. Okay. So now I'm going to use it to show you mechanical advantage. So I have a sheet of paper and I cut. I use the tip, as you can see. I used the tip. I made my cut very simple, very simple. very easy on the hand. I then take cardboard and hold it in exactly the same place. This is corrugated cardboard. As you can see, I hold it in exactly the same place and I cut. But now I'm applying a lot more force. I'm applying a lot more force. And because I don't have enough strength, this is what I'm doing. I am moving it now. I'm moving the cardboard further into the scissor. Further in. The cardboard was there. Now I'm moving it further in. And then I'm able to make the cut. Let's see what happens. Let's see what happens. There's the scissor again. For paper, the L happens to be here. I have the load here for paper. I have the load here for paper. When I use cardboard, I shifted the load to here. I put the cardboard here. Look what I am doing now. Look what happened. Look what happened. Look what happened. For paper, there's the system diagram. This is for paper. I have the load there. I have the fulcrum here. And I have the effort here. And it was so easy to press it. When I did cardboard, I had the load here, I had the fulcrum here, and I had the effort here. Look what happened. Can you see what I did? You noticed something. I want you to look at this. I want you to look at this. I want you to look at this. This is showing you load arm and it's showing you effort arm. That's what it's showing you. They're going to become very important when I'm going to explain the formula in a moment. I want to show you another example where we have load arm, effort arm changing all the time. This is a hedge clipper. This hedge clipper will be used to clip off tiny leaves and branches. So here's an example of a tiny leaf and a branch, and then obviously I'm going to put that into there and I'm going to be able to snip that off. So I've just snipped it off. But when I take this and I put it onto this part here, and as you can see it is much thicker. And I try to snip it and it's not so easy. And I'm trying to press it very hard and it wasn't so easy. So look at it again. There's the load, there's the fulcrum, and where my hand is the effort. Think and remember. But if I use a different tool and I use this one, observe this one. Look at this arm here. This is the effort arm. Effort arm will be from my hand all the way through to the fulcrum. There's the fulcrum there. And that will be the load arm because the branch goes there. Look now when I put the little branch there and I go with a cut and obviously it slipped right off like that. So let me observe this tool again. This is the load arm. Look how small it is. Look how small it is. This is the effort arm. Look how long the effort arm is. Look how long the effort arm is. Just remember those things. So let's move on. Now that we know about load arms and effort arms, I'm going to move further and show you how we do the calculations. What happens? In order to calculate mechanical advantage, which is MA for short, we always say effort arm is divided by the load arm. Let's go. Here's a lever. Here's an example of a lever. Here's a rock and here's a massive rock here. Let's see if somebody is going to get mechanical advantage moving that rock. So, here's the ground. Maybe I should have thrown it this way. Here's a massive rock. Firstly, you need to establish what kind of lever is that. First, second, or third class. So, let's see. effort, fulcrum, load. E, F, I. Fulcrum in the middle. I remember. Fulcrum in the middle is first class lever. Okay. So now I know I'm talking about a first class lever. So if this distance, for argument's sake, happens to be 3 meters, and this distance from there to the load happens to be 1 meter. So let's go to the formula. Equals effort arm. From the effort arm. From the effort to the fulcrum. From the effort to the fulcrum was 3 meters. 3. Divided by load arm. From the load to the fulcrum. From the load to the fulcrum. 1 meter. And I divide it, I get an answer of 3. That answer of 3 is wonderful because they say you get mechanical advantage when it is more than 1, which means it should be like that. 3 is more than 1. It means you got mechanical advantage. Understand? Happy everybody. That sounds good. Now, we're going to move to the next example. The next example I'm using is a broom. The broom, you all know, is broom there, effort over there, fulcrum over there, and load over there, because that is the broom. That is the third class. Remember, that was the first class. Third class is I, E, F. Look at that, what's in the middle. Remember that. So, look at that distance. Let's say that distance is 25 centimeters. And then look at that distance is 125 centimeters. So how does it calculate it? Let's go. MA is equal to EA over IA. EA is 25 over IA is 125, and when I divide it, I'm going to get 0, 0.05. 0.05 is way less than 1. Therefore, there is no mechanical advantage in third class lever. There is no mechanical advantage in third class lever. Okay, so what you gather from the whole lesson? You gather that mechanical advantage makes life easier. Mechanical advantage can be calculated if you know what effort arm and load arm is. How do you know effort arm? You look at the distance from the effort to the fulcrum. How do you know load arm? You look at the distance from the load to the fulcrum. What do you do with them? Effort arm divided by load arm. You're going to get an answer, and whatever answer you get, if it is more than 1, you got mechanical advantage. The job is easy. If it is less than 1, oops, you go into struggle. You go into struggle. Though you get the job done, but you will struggle. So, that brings us to the end of mechanical advantage. I hope everybody got the idea.